Hi. Once you're confident with rounding numbers, then you can move on to applying and interpreting limits of accuracy, including looking at upper and lower bounds. So, bit of a recap. If we are asked to round 9.45 kilograms to the nearest kilogram, then we would get 9 kilograms. We'd look at the 4 to the right of the whole number, and because it's less than 5, we'd stick at 9. What if we rounded 8.5 kilograms to the nearest kilogram? So in this case, again, we'd look at the number to the right of the whole number, and this time it's 5, so we'd round it up. So both of those numbers round to 9 kilograms to the nearest kilogram. So we can show this on a scale, that if we're rounding to the nearest whole number, or in this case, the nearest kilogram, that anywhere in between 8.5 kilograms and 9.5 kilograms, but actually not including 9.5 kilograms, would round to 9 to the nearest kilogram. And this shows us that if a measurement is rounded to a given degree of accuracy, such as to the nearest kilogram, then the exact value could be anything from half a unit below it to half a unit above that amount. So it could be anything from half a kilogram below to half a kilogram above. So a couple of examples here. If a bag of apples weighs 7 kilograms to the nearest kilogram, what is the least possible mass of the bag? So this is similar to the one we looked at before, and it would be 6.5 kilograms, because we half of a kilogram is 0.5 kilograms. We take that off the 7 and we're left with 6.5 kilograms that would round up to 7 to the nearest kilogram. Or the height of a person is 167 centimetres to the nearest centimetre. So what are the smallest and largest possible heights of the person? So the smallest height is 166.5 centimetres. As we're doing it to the nearest centimetre, we add and subtract half a centimetre from the height we're given. So if we subtract half a centimetre, we get 166.5 centimetres. And if we add the half a centimetre, we get 167.5 centimetres. So the actual height of the person could be anywhere in between those two values if it's rounded to 167 centimetres to the nearest centimetre. Next one, the age of a man is 40 to the nearest 10 years. So what are the range of ages his age could take? So as it's to the nearest 10 years, this time we half the 10, which gives us 5 years. So we add 5 onto 40 and we take 5 off of 40. So we can see that actually the man could be anywhere between 35 and 45 for his age to round to 40 to the nearest 10 years. If it was less than 35, it would round down to 30. And if it was 45 or up, it would round up to 50. So a slightly more complicated example. The mass M of a dog is 14.3 kilograms to the nearest tenth of a kilogram, which we can write as 0.1 kilograms. So this time, as it's to the nearest 0.1 kilograms, we're going to half that 0.1 kilograms to give us 0.05 kilograms, and we're going to add that on to 14.3 to give us 14.35 kilograms, and we're going to subtract it from 14.3 to give us 14.25 kilograms. So a mass in between those two values, 14.25 and 14.35, if we rounded it to the nearest tenth of a kilogram, would give you 14.3. And we can write it like this. The error interval, or the limits of accuracy, are written like this. So what this is saying is that the mass is greater than or equal to 14.25, and it's less than but it can't be 14.35 itself, anything up to 14.35, because if it were 14.35, it would round up to 14.4. So a bit of terminology. The upper bound is the upper limit for a measurement, and the lower bound is the minimum possible value for a measurement. So another example, if a book has a mass of 32 grams to the nearest gram, what are the lower and upper bounds of the mass? So as the mass is measured to the nearest gram, we're going to half that. So the lower and upper bounds, or the minimum and maximum values, are going to be half a gram either side of 32 grams. So we've got 32 grams, take away half a gram, which gives us 31.5 grams as the lower bound. And the upper bound, we're going to add the half a gram onto the 32 to give us 32.5 grams. So this is our lower bound, 31.5, and our upper bound, 32.5. And we can show the interval like this, like we did in the previous example. And it means that the mass of the book could be greater than or equal to 31.5 grams, and anything up to, but not including 32.5 grams, for it to have been rounded to 32 grams to the nearest gram.